Hello and welcome back. Why did I sell my vacuum cleaner? Because it was collecting dust. Okay, so today is going to be trig identities. And in other words, you're going to be learning how to prove certain trig identities. Now, there's a whole bunch here, and we're going to go through each of these ones. And then we'll go through a couple questions that show you the process for a proof. So first things, your reciprocal identities. Reciprocal just means if I had 1/2, the reciprocal of that is 2/1. We're swapping the fraction. So hopefully you remember, it's the third letter that kind of gives the hint away. Sec becomes 1 on cos theta, cosec becomes 1 on sine theta, and cot becomes 1 on tan theta. Okay, so whenever you see these, write it as 1/. Generally, you want to work with sine, cos, and tan. If I'm talking about my ratio identities, sorry about my writing, that looks pretty bad. But my ratio identities, I have tan theta. There's a ratio that kind of works like this. This is the ratio that relates sine, cos, and tan together. Okay, so tan theta can be written as sine theta on cos theta. And so cot, because cot is the reciprocal of tan, I can actually write that as cos theta over sine theta. Moving on, we've got the Pythagorean identities. These are probably the toughest ones to apply just because they're slightly different. This one here is given in your reference sheet. Okay, so sine squared theta plus cos squared theta equals to 1. Now that's a helpful thing because I can now write sine squared theta as 1 minus cos squared theta. And I can also write cos squared theta equals to 1 minus sine squared theta. It's just by rearranging, I can do that. Now, these ones are my two favorite ones. Courtesy to Mr. Woodbine for teaching me this. A man with a tan is sexy. I hope YouTube doesn't buy my account. And a man in a cot is cozy. Okay. So this is, not cos, cosec. Okay, so these two are not given in your reference sheet, but just remember, a man with a tan is sexy, and a man in a cot is cozy. Okay. We've also got this thing called complementary angles. Complementary is a fancy word that means add up to 90. So if I am ever given this kind of formula called sine 90 minus theta, it's complementary with cos. So cos is complementary with sine. It kind of works both ways. Cot is complementary to tan. So that means tan is complementary to cot. These are also not given, but if you remember one, you should remember the other as well. It just means something like maybe cos 10 is the same thing as sine 80. As long as the two numbers add up to 90, sine and cos are complementary, cot and tan are complementary. Okay, if you need to, pause those, rewind, rewrite those notes. Just take a note of what's given. They only give you this one, sine squared theta plus cos squared theta equals to 1. And they give you tan theta. And they also give you your reciprocal identities. Those should be given in your reference sheet. Cot theta as cos and sine is not given. Man with a tan and man in a cot, not given to you, but they're very helpful if you remember them. And your complementary angles, I believe, are also not given to you. Or maybe they are. I don't think they are. So yeah, now a prove. Well, generally, these trig identity questions, they'll say prove something equals to something, like you can see in that first question. So the way that a proof works is don't treat it as an equation. I should have written this before, my bad. Don't treat it as an equation where you can move things across by plussing and minusing. What you want to do is start on one side and then not rearrange, but just like use identities / algebra / how do I put it? use identities or algebra or just basic math to make it the other side. Okay, that was probably the least eloquent way I could put it, but let me show you what I mean. So I've got sine theta, cos theta, cosec squared theta is supposed to equal to cot theta. So the way that I'm going to set out my proof is I'm going to start with my left-hand side, and it's sine theta, cos theta, and cosec theta, cosec squared theta. And maybe if I can do this properly. And so what I'm going to do here is just work with what I know. Now, cosec, I know is 1 over sine squared theta. And I've still got the sine theta times cos theta times that. And notice how I'm not writing cot theta on this side. Just leave it. Okay, so I'm just going to keep working with the left-hand side. And this becomes, just by using math, sine theta cos theta on sine squared theta. I've got a common factor of sine theta on top and bottom, so I can cross one out each. That leaves me with cos theta on sine theta, and you can kind of see at some point when you get stuck, just take a look at the other side. Am I on the right track? Now I know that cot is 1 on 10, or in other words, cos theta over sine theta. That's one of your identities. So here I can just say equals to cot theta, and then therefore equals to the right-hand side. You've proven that your left-hand side equals your right-hand side. Therefore, I still don't know what QED stands for. I think it's quite easily done. I don't even know, but it's just kind of like a little statement to say, yep, I showed that the left-hand side equals the right-hand side. Okay, it's proven. Let's do the next question here. So now I've got 1 plus tan squared theta over 1 plus cot squared theta equals to tan squared theta. Now here I could try to work with tan squared x and cot squared x and try to rearrange those, but I know something about a man with a tan, and I know something about a man with a cot. Okay, so I'm going to recognize that for this one here, start with my left-hand side. What is a man with a tan? Let's write out the question. So continuing, a man with a tan is, you know it, sec squared. A man in a cot, you know it, is cozy. And now it still doesn't look like that. Still doesn't look like the right-hand side yet. And so what I'm going to do is I'm going to pick what's a bit more comfortable for me. I'm going to say that it's the same thing as sec squared x divided by cosec squared x, and then use that to kind of write sec as 1 over cos squared x divided by 1 over sine squared x. And at this point here, I just use my general algebra. If I'm dividing two things, I should probably, division of two fractions means KFC. I think of it as keep the first fraction the same. I'll write it down. Keep the first one the same, flip the second fraction, change from divide to times. So this is going to become sine squared over 1, and then I'm going to change it to times. This becomes sine squared x over cos squared x. And what do you know about sine on cos? It becomes tan. So this becomes tan squared x, and that equals the right-hand side. Therefore, QED, quite easily done. There you go. Hopefully that's making a little bit of sense. No two questions tend to be the same here. And so the more questions that you do here, the more prepared you'll be when you see a question like this come up in an exam. So have a go, keep trying. The best part is you've got the right-hand side, so you know what you're looking for. You just kind of have to kind of plot bit by bit, take one step at a time until you make it look like the right-hand side. All right, enjoy, and I'll catch you guys later. Bye-bye.